Why does understanding variability in data matter? Picture this. You're comparing two sets of data. They both have the same mean or average, but upon closer inspection, you find one set has a much wider spread than the other. This is where the concept of variability comes into play and why we need tools like standard deviation and standard error to quantify it. Dive into the realm of standard deviation first. Picture it as the heartbeat of a dataset, providing a snapshot of how values pulse around the mean. When the standard deviation is high, data points are spread across a wide range, pulsating far from the mean. In contrast, a low standard deviation indicates a tight clustering of data points around the mean, a steady, calm heartbeat. To calculate the standard deviation, take each data point's deviation from the mean, square it, and then average these squared deviations. Finally, take the square root of this average. This gives you the standard deviation, a measure of the average distance data points stray from the mean. Now let's switch gears to standard error. While standard deviation looks at the dispersion within a single sample, standard error is the measure of how much sample means differ from the actual population mean. Think of it as a measure of precision. A lower standard error suggests that the sample mean is a reliable estimator of the population mean. A higher standard error, on the other hand, suggests more variability between sample means and less reliability. To calculate the standard error, divide the standard deviation by the square root of the sample size. This step adjusts the standard deviation for the size of the sample, ensuring that estimates derived from smaller samples aren't overly influenced by their inherent variability. To summarize, both standard deviation and standard error are vital tools in the statistical toolbox. Standard deviation tells you about the dispersion of data within a single sample, while standard error gives you a measure of precision, indicating how reliably your sample mean estimates the population mean. Understanding these concepts is key to making valid inferences and informed decisions based on data. So, next time you're faced with a data set, remember to check its heartbeat and precision.